radiocarbon, tree ring, and valve dating. And this is our topic, and I hope you'll enjoy this. First of all, why study and discuss these three dating methods? Well, the answer is because old Earth Christian geologists vigorously parrot the secularist versions of these claimed evidences, claimed examples, where valve counts appear to have been successfully dated by radiocarbon and also match the tree ring chronology. And, these examples claim that we can show that radiocarbon dates materials at tens of thousands of years old, and therefore the Earth has to be more than 6,000 years old. Now, there's two examples of such apparent consilience, that is, agreement between these three dating methods, in a paper by two old Earth geologists that's promoted on the Biologos website. And what I want to show you this afternoon is close examination of these methods that are used in these examples show that these examples easily fall apart. So let's talk about radiocarbon to begin with. Radiocarbon is an abbreviation for radioactive carbon. Carbon has three isotopes, that's three types of atoms: carbon-12, carbon-13, carbon-14. You can see below in the diagram there that each of them have 6 electrons and 6 protons, but the neutron numbers are changed. All normal carbon is carbon-12. Radiocarbon is only a very minute quantity of carbon, and it is unstable and it decays. How is radiocarbon produced? Well, it's produced in the upper atmosphere. Cosmic rays from outer space bombard the upper atmosphere and produce high-energy neutrons. These neutrons interact with abundant nitrogen-14 in the upper atmosphere, and as a consequence, gets added to the nitrogen nucleus of the nitrogen atom and becomes carbon-14. That carbon-14 in the upper atmosphere combines with oxygen and forms carbon dioxide, and that comes down into the biosphere. And plants take in carbon dioxide when they have photosynthesis. And consequently, the air that we breathe has carbon dioxide, of course, and therefore it has radiocarbon in it. Animals absorb the radiocarbon when they eat the plants, and they keep adding more carbon-14 to replace what decays away. So in other words, the food you ate at lunch had radiocarbon in it. You all have radiocarbon in your bodies, and if this is a nuclear-free zone, you should all be banned from being here. Now, the issue is what happens when plants and animals die. Guess what? You stop eating, which means you stop taking in carbon-14. The amount of carbon-14 still left in your bones decreases while you're buried out there in the graveyard. And the older your bones become, the less radiocarbon they contain. So, what do? Well, we can measure the carbon-14 in buried animal bones. Say we find some dead animals. We want to know how long ago they died. Well, we can compare the amount of radiocarbon in the dead animal's bones compared with living animals' bones. If we know the rate at which the radiocarbon decreases, then we can figure out how long ago the animal was died and buried. And that is how you obtain a radiocarbon age. Not that difficult to understand. So radiocarbon decays back to nitrogen-14 at a steady rate which can be measured. Its decay rate is expressed in units of half-lives. What do we mean by that terminology? Well, if you start with a pound of radiocarbon, within 5,730 years, which is one half-life, you'll have lost half of that, and so you'll have half a pound left. In the next 5,730 years, you'll lose half again. So at the end of that period, you'll have only a quarter of a pound left. And so it goes on. And that means the radiocarbon declines over a period of time. And essentially, by the time you get to 10 half-lives, there's virtually none left. In fact, if every atom of the Earth was made up of radiocarbon, within 1 million years, it'll all have decayed away. There's absolutely none left. Now, that means that if fossils truly are millions of years old, they should contain no radiocarbon, what geologists refer to as being radiocarbon dead. And that's why they don't date fossils with radiocarbon. They believe the dinosaur bones are 70 million years old or more, so they never date the bones with radiocarbon because they already believe they are millions of years old. Now, since the 1980s, the technology to measure radiocarbon has improved, so much so with the advent of accelerator mass spectrometers, or AMS instruments. You can actually count radiocarbon atoms in a sample, literally count 1 in a trillion atoms. This is what it looks like in diagrammatic form, and this is what it looks like in a laboratory. You get your sample, you get it, vaporize it, you draw it through a magnetic field that bends the beam, and essentially because it beams, the different weights of carbon, atoms separate, and so you can actually measure the amount of radiocarbon in your sample. The principle is simple, the technology is quite sophisticated, and it costs a lot of money. So, these instruments can theoretically detect radiocarbon in materials down to 0.001% modern carbon, which is equivalent to a conventional age of 95,000 years. That's the theoretical limit for these instruments. But the practical limit is more around 60 to 70,000 years, and you'll see why in a moment. Now, radiocarbon dates appear to be very good matches for historical dates back to about 400 BC in the biblical chronology. The further one goes back, the greater divergence of radiocarbon dates from historical dates in the biblical chronology. Nevertheless, the reliance on calibrated or corrected radiocarbon dates, and I'll introduce that term now and we'll say more about it, calibrated radiocarbon dates appear to fix the Egyptian chronology in such a way that there looks like a good correlation between the two. But remember, we're talking about corrected or calibrated radiocarbon dates. So the next question is, how do they do that calibration? You see diagrams like this that seems to show a very good correspondence between radiocarbon ages and historical ages, say for Egyptian archaeological materials. However, even secularists have been concerned about the problems with radiocarbon dates as you go back in time. For example, the minute quantities of radiocarbon involved in the materials that you're analysing are swamped and could easily be swamped by contamination. Contamination could occur in situ during handling of the materials in the field or in the laboratory, or from the lab equipment, such as the instrument, the accelerator mass spectrometer instrument itself. So, what they did in the early 1980s, they wanted to check their instruments and check their laboratory equipment. And they wanted to see if there was any contamination. First of all, they tried to eliminate the contamination and were comfortable that they had with their pre-treatment of the samples. What they do is they treat the samples with repeated washings of hot, strong acids, that is hot, heated up, acids which are very corrosive, and also alkalis. And that removes contamination such as from carbonate, lime. And most laboratories will tell you that their treatments remove all contamination from handling in the field and handling in the laboratory. And yet, when they tested samples with their instruments, samples that were supposedly millions of years old and should have been radiocarbon dead, what did they find? Every sample of coal, fossils, oil contained detectable radiocarbon. Now, they even put empty sample holders into their instruments and got a 0 result. So that means the contamination couldn't be from the instrument. Therefore, they should have concluded that the radiocarbon they measured in coal and fossils was intrinsic to those samples, and therefore the samples were young, not millions of years old. But of course they refused to accept that. And even though they've published it in the literature, in fact you can search the literature, the journal Radiocarbon, for example, and you will find that materials that conventionally are dated as far back as 540 million years old have all been analysed, and they have detectable, measurable radiocarbon in them, which they should conclude means that those samples are not millions of years old. Now, I began researching this issue back in the 1990s. I wanted to prove it to myself, and so what I did, I started collecting fossilised wood samples from various locations around the world of supposed geological ages up to 250 million years old. And of course I sent them off to laboratories blind. I didn't tell them where the samples had come from, and they all gave ages of only thousands of years. So for example, here's a fossil wood from a Jurassic, 189 million year old rock in England, and it gave a carbon-14 age of 24,000 years. Here's fossil wood from a 250 million year old coal seam or coal bed in Newcastle, Australia, and it gave an age of 33,700 years, radiocarbon age of 33,700 years. Here we see fossil wood from a volcanic bed 1,700 feet down in the Crescent gold mine in Cripple Creek, Colorado. And it yielded a radiocarbon age of 41,000 years. Finally, and I could give you other examples, but this is an interesting one because there were two materials dated. There was fossil ammonite shell and fossil wood together in a mudstone in Redding, Northern California. Conventionally dated 112 to 120 million years, we see radiocarbon ages between 42 and 48,000 years. Now, during a research initiative called the Radioisotopes and Age of the Earth Project, RAT is the acronym, between 1997 and 2005, that I was involved in, we got 10 coal samples from around the US that were stored under carefully controlled conditions by the Department of Energy at the Penn State University. We applied for these, they're available for research, and we sent them off for radiocarbon dating. And what did we find? Well, these coal beds vary in age, conventional age, from about 40 million years down to over 300 million years, the Pennsylvanian coal beds of the Appalachians. And these were all sent to laboratories, and what did we find? We found that all 10 coal samples contained similar amounts of radiocarbon, regardless of their conventional ages. The mean or average was 48,500 years. Now, what does that tell you? It means that these trees all lived at the same time and died at the same time. Where did the coal come from? Coal is buried vegetation, buried at the time of the flood. In other words, pre-flood trees that lived at the same time were all buried at the same time during the flood. So would we expect them to have the same radiocarbon age? Yes, and that's exactly what we found. And now we need to think about, well, wait a minute, if wood, shelf, bone, fossils, coal, oil, natural gas all contain radiocarbon, what about these ages that seem rather large compared to the biblical chronology? We need to think about that again in a moment. But if we take into account correction factors, then we can certainly recalibrate these radiocarbon ages to fit with the biblical timescale. Now, in our research, we not only did coal samples, we also collected some diamond samples. We applied for samples of diamonds from Africa through the University of Glasgow, Scotland, and we sent these 12 samples of diamonds off to the lab for radiocarbon dating. And here's the results. You can see some of them come from hard rock diamond mines, kimberlite mines, and some were from alluvial deposits in various parts of Africa. And we found that all 12 diamonds contained measurable amounts of radiocarbon equivalent to radiocarbon ages between 45,000 and 60,000 years. Now, where did this radiocarbon come from? It couldn't be from external or internal contamination because diamonds are impervious to that. They're the hardest substance known, natural substance known. Nor could the radiocarbon have been produced by in situ bombardment of nitrogen by neutrons. Now, nitrogen is found in diamonds in minute quantities. And yes, there is sometimes uranium in diamonds. And you'll find on blogs, skeptic blog sites and websites, claims that the radiocarbon in diamonds could be produced as a result of this neutron bombardment from uranium decay of nitrogen. Well, guess what? We've responded to that argument now for over 10 years, and they refuse to accept the answers we give them. They keep repeating the same arguments that have been refuted. The level of uranium is not sufficient to produce the levels of measured radiocarbon in the diamonds. End of story. That means the radiocarbon in the diamonds has to be in situ. But wait a minute. These diamonds, I'll come back to that in a moment. I'll interpret that for you in a moment. What I want to share is that others went out and also tested diamonds. We presented this information at the fall conference of the American Geophysical Union in San Francisco about 2003, and two scientists from the University of California, Riverside Radiocarbon Lab saw our work and went away and got their own diamond samples to test for radiocarbon. And guess what? Their 8 diamonds yielded ages from 65 to 80,000 years. And they cut a 9th diamond into 6 equal fragments, and all 6 fragments yielded a roughly the same radiocarbon age, which means the radiocarbon was evenly distributed through that diamond and intrinsic to the diamond itself. Now, we have to remember that diamonds form 100 miles down inside the Earth's mantle. So they've never been in contact with the Earth's atmosphere. Remember we said that radiocarbon is produced in the atmosphere? Yet these diamonds formed inside the Earth. So this can't be radiocarbon derived from the atmosphere. It has to be radiocarbon that's intrinsic to the formation of the diamonds themselves. But the diamonds are conventionally dated between 1 and 3 billion years old. The radiocarbon indicates that, therefore, the diamonds are only thousands of years old and therefore only formed thousands of years ago. So if the diamonds are intrinsic to the very formation of the Earth itself, then the Earth itself is young too. Now, what about this issue of calibration and correction? Why is it that we get even tens of thousands of year old ages instead of the biblical chronology of only about 6,000 years? Well, there are several ways in which the carbon-14 in the Earth's atmosphere and therefore in the biosphere, therefore in the samples that we measure, can be affected. First of all, we do know today, it's actually been measured, that there are atmospheric variations in carbon-14 between the northern and southern hemispheres. We also know there are variations in the natural carbon-14 production rate related to cosmic ray influx from outer space. And then there are alteration effects, such as fractionation. That is, the different sized atoms or isotopes of carbon can preferentially be taken in by different organisms or plants. And so you separate the isotopes, and that skews your measurements. Then we can get in situ production of carbon-14 within trees as a result of the nitrogen-14 in trees being bombarded. Then there's the effect of recrystallization in shells. And then there's also volcanic eruptions contaminating the atmosphere, because what comes out of a volcano? Gases that also include carbon atoms. And of course, we've messed it all up. When we blew up the atomic bombs, what happened? We added carbon-14 to the atmosphere. That's why you'll see carbon-14 dates are usually quoted as pre-1950. 1950 was when we contaminated the atmosphere with carbon-14 from nuclear bombs. Well, interestingly, variations in the natural carbon-14 production rate due to cosmic ray influx is controlled by the Earth's magnetic field. The Earth has a magnetic field, which is why a compass needle points north. Now, real-time measurements of the strength of the Earth's magnetic field over the last 200 years has shown that it is decaying at a rate of halving every 2,000 years approximately. So 2,000 years ago, the Earth's magnetic field would have been twice as strong as what it is today. You go back 4,000 years, it would have been 4 times as strong as it is today. And that would affect the influx of cosmic rays. A stronger magnetic field shields the Earth from cosmic radiation. And if it's shielded it from cosmic radiation in the past, that means there'll be less carbon-14 produced in the past. So if you calculate your radiocarbon date based on today's carbon-14 production rate, you're going to overestimate the radiocarbon age, because in the past there was less radiocarbon. And so you'd have a lower production of carbon-14 in the past because of a stronger magnetic field. Of course, there were fluctuations in the past. We know that because we see evidence of reversals of the Earth's magnetic field back to the time of the flood and during the flood. By the way, we can check this. Sometimes we can actually measure from pottery grains that have been trapped when the clay was baked, that we're able to determine what the strength of the magnetic field was back from those potteries from archaeological materials. So the Earth's magnetic field, therefore, being stronger in the past, limits the Earth's age to less than 10,000 years, depending whether we have a dynamic decay model or a free decay model. And of course, there'll be changes during the flood. It goes back, the Earth could only be 10,000 years old at the very most. Otherwise, the Earth's magnetic field would have been stronger than that of a magnetic star. So, as I said before, this means calculating radiocarbon ages, assuming a constant magnetic field, and therefore a constant carbon-14 production rate, will grossly make the ages older than what they should be, especially beyond about 500 BC. Now, how do the secularists get around this problem of calibrating radiocarbon? Well, they derive a calibration by counting the growth rings of trees. They have developed tree ring chronologies based on the wood from living and dead trees, assuming 1 growth ring per year, and we'll come to this issue shortly. Let me finish the radiocarbon story before we talk about tree ring dating. So, what does this demonstrate? This demonstrates that ultimately radiocarbon ages are calibrated against tree ring chronology, and that means the radiocarbon is not independent of other methods. It relies on other dating methods to produce calibrated or corrected ages. And so radiocarbon is only as good as what the other methods are. Now, we know that there are variations in carbon-14 dates relative to tree ring dates prior to 1950, when we contaminated the atmosphere with nuclear explosions. There's first of all the Zeus effect. When we started burning fossil fuels, we added more normal carbon into the atmosphere, carbon-12, and that changes radiocarbon dates from that period onwards. And then earlier on, there was the so-called Maunder minimum. That was when there was such a low amount of solar flares and sunspots that the cosmic ray influx was much lower. And so that also perturbed radiocarbon ages. Now, this begs the question, if these effects are known, where they can be detected, what about where they cannot be detected, where we don't have any cross-checks? Again, it begs the question as to how reliable radiocarbon ages are. In fact, when we calibrate radiocarbon against tree rings, we find that radiocarbon becomes more and more out of sync the further you go back in time. In fact, corrections that must be added to carbon-14 dates to bring them into agreement with tree ring dates. These systematic deviations of radiocarbon from tree ring dates are caused by variations in the carbon-14 concentration in the atmosphere in the past 6,000 years that we know of. So, these discrepancies between radiocarbon and tree ring dates are up to 750 years. Thus, there are several recalibration curves that the secularists have developed for radiocarbon ages that depend on tree ring chronologies. The interesting thing is every few years there's an international panel that revises, updates and publishes the latest calibration curve. So they're always tinkering it. It's not absolute. One always has to check when you read a radiocarbon age. I mean, you won't hear this from the reporters in the newspapers because they don't even understand any of this. And they make it sound as if radiocarbon has proved the age. But what they don't tell you is the radiocarbon age is calibrated or corrected. So if you really want to know whether it's a true age or not, you have to ask whether it's been calibrated and what it's been calibrated against. Here, for example, is one such radiocarbon calibration curve using the tree ring chronology as the absolute standard. Notice there's a discrepancy between radiocarbon and tree rings. The further back you go, the larger the carbon-14 ages become, more inflated by thousands of years. And so here's another graph. It shows uncalibrated versus calibrated radiocarbon ages using tree rings. And the discrepancy is 1,000 years, supposedly back at 5,000 BC. So, how accurate are the tree ring ages? If that's the standard, how accurate are they? We'll come to that just in a moment. What we urgently need, therefore, is a model from a biblical perspective using the biblical framework to correct radiocarbon ages. We could actually turn radiocarbon from being contrary to the biblical chronology to using it to calibrate the ages of archaeological materials so they fit with the biblical chronology. So the biblical model has to take into account the Earth's stronger magnetic field in the past, what happened during the flood, the obviously larger, more prolific biosphere in the pre-flood world as evidenced by the magnitude of the fossil record. Pause there a moment. 95% of the fossil record by volume and number are corals, clams, shallow water marine creatures, the sorts of fossils that you find if you dig under this museum, the sort of fossils you find in the road cuts all around the Cincinnati area. 95% of the fossil record is full of those critters. So that means the coal, of which there's 7 trillion tonnes in the US, is in the less than 5%. So that gives you an idea of the volume of these critters that are buried in the fossil record. Do we see a similar volume of living corals and clams today? No. The present world is a desert compared with the prolificness of the biosphere in the pre-flood world. So what does that mean? It means that in the pre-flood world there was far, far more normal carbon than what we have in the world today. Because a lot of that normal carbon got buried in the fossil record. So the pre-flood world was different. We have to take that into account. Quantifying these factors is hard, but a way to do this calibration is to get carbon-14 dates for samples that are related to known historical dates in the biblical chronology. In other words, if we could guarantee a certain artifact dated from the time of Abraham, we know from the scriptures when Abraham lived, we could get a radiocarbon date and therefore we would know how much radiocarbon was inflating the age at that time, and we could recalibrate. So, for example, we know already that artefacts from the time of King David give you carbon-14 ages that are 500 years too old. So we already know that there's a correction factor of 500 years for artefacts from the time of King David. Now, one factor which can be quantified is the time it takes for equilibrium to be re-established as a result of carbon-14 entering the upper biosphere again after the flood. If the atmosphere was cleansed during the flood by all that rainfall, etc., then you have to start from scratch again and build up radiocarbon. And we call this the mean life. The calculated resident time you keep on adding is only a half-life. The mean life, the half-life, as it were, of this build-up is 375 years. So within 1,100 years after the flood, you would reach 95% equilibrium. And after 5 mean half-lives, or 1,700 years after the flood, you would effectively reach equilibrium again. So that's the curve. So after the flood, you've got a period where you're going to re-establish the level of radiocarbon, that we have today. So that means in that period, you have to factor that in to your calculations as to the calibration of a radiocarbon age. And as I said before, we can definitely assume that a stronger geomagnetic field and a richer biosphere before the flood lowered the net radiocarbon production rate prior to the flood. And that after the flood, there was a rapid increase in carbon-14 build-up, particularly in the early post-flood period, until net equilibrium was reached. As a result of the flood, the biosphere became impoverished, as I said before, compared to the pre-flood world. Thus, the percent modern carbon level, that is the ratio between radiocarbon and normal carbon in the upper biosphere, rose rapidly from a low pre-flood level within the first few centuries post-flood to reach near modern levels. And so here are some possible modelling curves that we could use to start thinking about this issue of understanding the history of radiocarbon based on the biblical view of Earth history and its time frame. Now, as I said before, though, to achieve this, we need to quantify the recalibration of radiocarbon ages, and the best way ultimately is to achieve this with anchor points where we've got radiocarbon ages for samples of known historical ages. And this is a work in progress. In fact, this is an example of a calibration curve, and we hope that in the years to come we'll be able to produce a recalibration curve. So the quest to find these anchor points is to find samples of radiocarbon ages of known historic ages. We already have carbon-14 ages of fossil materials from the flood. We've already seen that. I've given you examples. And we also know radiocarbon from materials, ages for materials in the early post-flood world and the Ice Age. So it means that we can use some of that information already in the literature to start working out a recalibration curve. And you'll understand that this will greatly assist biblical archaeology in our understanding of the early post-flood world. Meanwhile, we can definitely conclude that radiocarbon ages are not true historical ages and that they are needing drastic revision to fit the biblical chronology. But we are getting closer to achieving a recalibration of radiocarbon ages to fit the biblical chronology. But we need to remember the secular community still calibrates radiocarbon ages with tree rings and other chronologies, so radiocarbon dating ultimately is not independent. The way they use it, it's not independent. It relies on methods such as tree rings. And so we need to now go to this issue. Are tree ring counts and their chronologies reliable? Well, what are tree rings? Tree rings in woods, in tree trunks, are growth rings. The rate of growth of trees, and therefore the widths of their growth rings, is determined by the soils, the altitude at which the trees are growing, the water table, climate, seasons and weather. Droughts and fires, for example, and periods of abnormally high rainfall will impact the growth pattern of trees and therefore the rings that they produce. And therefore it's not necessarily true that there will always be only one growth ring per year. That's an important point to make. Here's an example of a tree that's been cut down, and you can see the growth rings. You can see the first year of growth there at the centre. You can see wider rings that indicate a rainy season and narrower rings that indicate a dry season. And then you can also see a scar from a forest fire where the tree was burnt. The outer edge of the tree was burnt. Many tree rings are very small, very thin, which makes counting them very difficult. Real-time monitoring of tree growth, by the way, in Australian forests has been documented by a friend of mine who used to work for Australia's government research agency, and he told me that multiple rings were found to form in 1 year, and growth spurts correlated with rainfall events, not necessarily with the seasons, because in parts of Australia you don't get great variation between the seasons. It's rainfall events which are more likely to cause the trees to grow. If you have multiple rainfall events in any 1 year, you'll have multiple growth rings. Yet it's normally assumed that you get one growth ring per year. The early wood in the spring, summer, the late wood in the fall and winter. And the other thing to know is that the growth rings in trees in the same forest can vary enormously. You can cut down two different trees in the same forest that are adjacent to one another, and their tree ring pattern will be different. And that's important to remember when you see how they go about this dating method called tree ring dating or dendrochronology. It's the science of counting up the growth rings of specific trees, but also they go to timbers in historical buildings. These are from trees that were cut down in ancient times and sawn to build beams in houses. And so what they try to do is match the patterns of rings in the timbers in houses and buildings with one another to build up a master chronology to calibrate radiocarbon ages. And once they get radiocarbon ages, they can use these chronologies to date wooden objects of unknown ages. This involved matching the rings between the different samples and the ring patterns of unknown age dead trees or timbers with those of living trees, or with timbers that have already been assigned a position within the master chronology, tree ring chronology. How is this done? Well, first of all, we can see that in this tree, the growth rings in the wood of large trees are clearly evident when the tree is felled. Each growth ring, the tree's early growth rings are generally wide, representing good years, but you can see the more recent growth rings are thinner. So the later years were drier and harsher. Also, of course, as the girth of the tree grows, the growth is going to be spread around a greater circumference, and so they're likely to get thinner anyway. How do they measure these tree rings on living trees? Well, they get a hollow drill and drill into a tree, and the wood that stays in the hollow section, when they pull the drill bit out, they can take that out to form a wooden core. And then they lay out these wooden cores to compare from one tree to the next. And so what do? Here we can see at the top left, we can see a tree sampled in 2007, a living tree. And they compare it to a drill core, a core of timber taken from a wooden beam in a building, okay? And they try to match the rings visually. So what do they try to match visually the pattern between the living tree and the wooden beam. And then they get to an older building, and they might know the age of the building when it was built, and they try to match the rings again. But it kind of helps you if you know when the building was built, don't you, from historical records. What about where you've got no independent historical evidence to know the age? It becomes very, very subjective. Here's another example. where they took a living tree, and we're moving from right to left in this instance, a living tree, the rings there compared to a beam from a house, and then an older house, 1, 2, and 3, across from right to left. You can see how this was built up. Where a forest has been affected by historic volcanic eruptions, that can also provide an independent cross-check. So, for example, you can see there you might get a missing growth ring that corresponds to the year of the volcanic eruption. But the problem is this matching of growth rings is still subjective. It's in the eye of the beholder. This process of matching growth rings is called cross-dating or cross-matching. Such matching is done visually and looks very obvious and easily done. But growth rings are complex, and thus cross-matching is very subjective according to the eyes of the scientists doing the cross-dating. The interesting thing, when this work was done early, in the early years of this work, the work was done at the University of Arizona, Tucson, and they refused to allow people to see the raw data from which they obtained their chronologies. It was kept under lock and key. So no other scientists could verify how accurate they were in the matching of their ring patterns. Counting growth rings is tedious, and matching ring patterns and specific growth rings from sample to sample where there are visual similarities is highly subjective. As I said, given that there are variations from tree to tree in a forest, and thus in the wooden beams used to build houses. Therefore, what do? They use radiocarbon to date the growth rings so that they can attain approximate ages to an associated pattern of rings, a wiggle, that can then be matched at the appropriate time in the tree ring chronology. This is called wiggle matching. That's the official term. And carbon-14 dating is critical. So what they do is they sample the tree rings in a core and radiocarbon date them, because they don't know where this sequence of rings fits into the master chronology. And then when they've done the radiocarbon dating, they say, aha, this ring fits in about 2,000 years ago, and then they move it into the master chronology to see if it fits back there 2,000 years ago. So it's a very subjective, but here's the point. The tree ring chronology is based on help from radiocarbon. What did I say before? Radiocarbon is calibrated against the tree ring's chronology. You're arguing in a circle, which is a logical fallacy. Now, the most famous tree ring chronology, which is claimed to be greater than 9,000 years long, has been constructed from groves of bristlecone pine trees. There's 3 species of bristlecone pines, and all 3 species are found in high mountain altitudes in the southwestern US. They're long-lived, they're highly resilient to the harsh weather and the bad soils in these areas. So here's a map of groves, where you find groves of these Great Basin bristlecone pines, particularly the species Pinus longivera, which is found in Utah, Nevada, and eastern California. The most famous location is in the White Mountains of eastern California. And there you've got growth, the mountains go up to 11,000 more feet or more above sea level. And this is the species that's been used to construct the bristlecone pine chronology. Here's a grove of bristlecone pines in the White Mountains. You can see it's very desolate, very dry, very harsh climate. These bristlecone pines are found in isolated groves just below the tree line at elevations between 5,600 and 11,200 feet on dolomitic soils. Dolomite is magnesium calcium carbonate. It's limestone with a bit of magnesium added to it. By the way, the interesting thing is no one has ever explained why it is the trees get older as you go to higher altitudes. That's interesting. Altitudes may have something to do with the supposed age of these trees. These trees grow in soils that are shallow and are usually derived from dolomite and limestone. So they're very rich in calcium carbonate and magnesium. They're highly alkaline, they're low in phosphorus, and these are factors that they exclude other species, but yet the bristlecone pines thrive under these harsh conditions. They grow very slowly in the cold temperatures, the dry soils, the high winds, and they have short growing seasons. As the trees age, much of their vascular tissue dies, so that in very old specimens, only a very narrow strip of living tissue connects the roots to a handful of live branches, as you can see in that photograph there. The tree looks half dead, and it is, it's half dead. These ancient trees have a gnarled and stunted appearance, especially those found at high altitudes. In fact, the apparent oldest trees are found at the highest altitudes. They have reddish-brown bark with deep fissures. Because they grow very slowly, their growth rings are very, very thin, and they're exceedingly difficult to count. The wood is very dense and resinous, resistant to invasion by insects, fungi, and other potential pests. The tree's longevity is partly due to the wood's extreme durability. While other species that grow nearby suffer rot, bare bristlecone pines can endure even after death and are often still standing on their roots for many centuries. Rather than rot, the exposed wood is eroded like stone due to wind, rain, freezing temperatures, etc., which produces sculpted forms like this one here. So these bristlecone pines are known to attain great ages. Well, that's if you believe the tree ring counts. The oldest living tree is claimed in the White Mountains to be over 5,000 years old, according to the measurements that evidently have been made, but its location is kept a secret. Another tree in the White Mountains is called Methuselah. It's claimed to be over 4,800 years old, but its location is kept a secret. Why? Because they don't want people defacing it. Here's the grove where the Methuselah tree is known to be, but we don't know which one it is that's Methuselah. Another famous grove of bristlecone pines is in Utah. But in 1964, an obviously ancient tree was accidentally cut down. Prometheus, this was the code name for that tree. It's reputed to have had over 4,800 growth rings. And here's a grove of these trees in Utah, in the same place. And here's the tree, the remains of that pine tree that was cut down inadvertently. Now, due to the harsh conditions these trees grow in, it is likely that a growth ring did not form every year. Maybe more than one ring grew in wetter years. We don't know. And we really don't know whether these are true ages for Prometheus being 4,900 years old, or the specimen in the White Mountains that's claimed to be over 5,000 years old. Here again are the remains of that ancient bristlecone pine in Utah. Now, the bristlecone pine tree ring chronology was first constructed back in the 1970s and supposedly extended 7,000 years. It was extended in 1983 and is now claimed to go back over 9,000 years. But here's the interesting point. The living trees only account for the first 1,200 years or so of the chronology. And there are only 2 specimens where the living and dead tree rings overlap. One specimen of a living tree and one specimen of a dead tree has produced that overlap. Most of the growth rings were counted on dead trees, although many of these are supposedly still standing. So you can see there on the right hand up the top, the living trees only go back about 1,200 years for their rings. Notice there's only one specimen of a living tree and one specimen of a dead tree connect this whole chronology. So that immediately is suspect. In 1970, and the data's been kept secret, so you can't go and check how they did the matching. In 1970, a data set of 315 radiocarbon measurements were made on a collection of bristlecone pinewood samples used to establish the master tree ring chronology. This was pre-1980, so it was using the older technology. But these younger ages would not be such a major factor in the accuracy of the radiocarbon ages. What is a factor? What kind of soil does these trees grow in? Limestone and dolomite soil that contains a lot of extra normal carbon. So these trees are going to take up from the ground moisture that adds extra normal carbon, which is going to dilute the radiocarbon, which is going to make the radiocarbon ages older than what they really are. And yet they've used the radiocarbon to help calibrate their tree ring chronology. Other master tree ring chronologies have been constructed from oaks in Ireland, Britain and Europe, and some have been claimed to go back beyond 10,000 years. But every one of these tree ring chronologies relies both on radiocarbon dating and wiggle matching. Where the growth rings are thin, there can be no guarantee as well that the wood samples obtained for radiocarbon were from individual rings. If they're going to sample a very thin ring, how can you be sure that when you scrape your sample out, you're not dating more than one ring at the same time? So, tree ring dating is not independent of radiocarbon dating. Finally, what are varves? Varves are sedimentary beds or laminae deposited in a body of still water, usually a lake. It's a thin pair of graded layers seasonally deposited, or so it's claimed, in a lake. A glacial varve normally includes a lower summer layer consisting of relatively coarse-grained, light-coloured sediment, usually sand or silt, produced by rapid melting of ice from a glacier in the warmer months, which grades upwards into a thinner winter layer consisting of very fine clayey, organic-rich dark sediment deposited in suspension in a lake. Well, here's another definition from the same dictionary. Any cyclic sedimentary couplet also found in shales that are mudstones and other rock layers. Where did this word come from? It's Swedish, varv for layer, and it means a periodical iteration of layers. Well, we've got another term for such a phenomenon. It's called a rhythmite. A rhythmite is an individual unit of a rhythmic succession of beds developed by rhythmic sedimentation and carries no time or seasonal connotation. It's very important. We'll come back to that issue in a moment, and you'll see why. Let's first focus on varves. They're laminae, or a sequence of laminae that's very thin layers stacked on top of one another that are deposited in a body of still water, such as a lake. And so it's claimed that you have thin layers that are graded and sorted according to the temperatures, the climate, the winter and summer seasons. And you can add up these pairs of fine and coarse-grained laminae in a cyclical pattern to count the years. And so it might be constructed from organic materials, it might be constructed by the grain sizes of the material. So here, for example, we have claimed varves in a former glacial lake in Montana. And you can see that there's a variation between these thin bands. And they decide that if they look at the couplets that are different from one another and add up these couplets, that you can have one couplet per year, and so you can date these sediments as taking thousands and thousands of years to accumulate. So varve dating is very similar to tree ring dating. The claimed annual varves, the couplets of summer and winter deposition, are counted to build a varve chronology extrapolated backwards from the present day sedimentation that's going on in the same lake. You look at the sediments in the bottom of the lake compared to what's happening at the top of the lake, the bed the lake floor today. Now, this assumes that deposition has always been the same rate and pattern as we see today, extrapolated back in the past. It is also assumed that these couplets are always varves. But what if they weren't varves? What if they were rapidly deposited rhythmites as a result of storm events that may even have occurred on a weekly basis? They've never really faced that issue. They assume that they are all varves to build these chronologies. Closer examination of some examples is necessary to explore the question of whether what are called varves are really genuine varves or whether they in fact are rhythmites. A related issue is whether extreme depositional events such as storms are capable of depositing multiple layers, laminated layers, all at once that would otherwise be regarded as rhythmites. So let's go from situations where we can actually observe what happened in an extreme depositional event that in fact deposited multiple laminated layers. And then let's compare deposits formed like that with what is being claimed as varves. And I think you'll see this is very powerful. Well, Mount St Helens in 1980 erupted. The original blast was followed by landslides, volcanic ash flowing on the ground through mud flows, steam water, falling volcanic ash. These catastrophic processes produced a complex of sediment layers up to 600 feet thick. The most surprising accumulations resulted from slurries of volcanic ash that moved out of the volcano at velocities up to 90 miles per hour. So here we see these volcanic ash beds exposed in the walls of a canyon. You can see the person there for scale. These deposits were filled with different layers, including many fine volcanic ash beds ranging in thickness from a tiny fraction of an inch up to 3 feet thick. Yet each bed was laid down in just a few seconds to several minutes. And one such layered deposit was 25 feet thick, and it accumulated within 3 hours during the evening of June 12, 1980. On that evening, a volcanic ash flow came out of the volcano, mixed with water, and the flow moved at hurricane velocity of 90 miles per hour. And that's what it produced. 25-foot thick sequence of layers on June 12, 1980 in 3 hours. Geologists were staggered that so many varied sediment layers, alternating fine and coarse bands with laminae and even cross beds and graded beds, that was the sizes of the grains were changed as you went up through these beds, could be produced by a slurry moving at more than freeway speed. Many of these thin laminae were alternating pattern of fine and coarse thin laminae, exactly as you'd find in varves and rhythmites. But they were not deposited by alternating conditions through summer and winter. They were deposited all at once from the same slurries. So let's look up close at these beds. Let's zoom in a bit closer. See the bands of coarser particles and bands of finer particles? These are not varves. These were instantaneous rhythmites. Out of the same slurry, you got alternating bands of coarse and fine-grained laminae. Go in even closer. You can see the scale of these fine bands that alternated, and all happened as a result of one catastrophic volcanic event. Mount St Helens emphatically teaches us that multiple sedimentary layers do form very rapidly by catastrophic flow processes similar to those which would have occurred during the Genesis flood. Now, of course, volcanic ash behaves differently from waterborne silt and mud, but the depositional processes are essentially the same. So this demonstrates that rhythmites, which look like varves, can be deposited virtually all at once in an extreme catastrophic event. And thus, if you were to count the fine and coarse-grained laminae, thinking they were varves, you would get the wrong count. They do not indicate deposition over thousands of years. Now, what happened at Mount St. Helens? Is that a lone example? Absolutely not. Hurricane Donna in 1960 flooded southern Florida, and it deposited a 6-inch thick mud layer with numerous thin laminae in it. From the one surge from the hurricane, you produced a 6-inch bed with multiple laminae in it. A 12-hour flood in June 1965 in a creek in Colorado deposited a sediment layer with more than 100 laminae. Just from one flood, 100. More than 100. And recent sedimentation in Lake Walensee in Switzerland reveals an average of 2 laminae, and in some years as many as 5, from rapid underwater flow processes. Not by seasonal fluctuation, just by rapid influx of water into the lake with sediment. One of the prime examples you'll see in the literature comes from the Green River Formation of Wyoming, Colorado, and Utah. That's long been claimed to be the result of varves deposited in inland lakes. Yet all such claims derive from a study back in 1929. And all the secularists repeat the claims every year. It's claimed, for example, that there are 1 million annual pairs of varves in the Green River Formation. So it's claimed that deposition took up to 7.5 million years. Yet, if you look closely at these varves, so-called varves, you'll find there are occasionally pebbles. Now, pebbles require much faster water flow to move them. And these pebbles have laminae draped over them. You can see one there in the bottom left-hand corner. So you need a faster water flow to move the pebble. Therefore, the laminae were also produced by faster water flow because the laminae are draped over that pebble. Also, there are numerous thin volcanic ash beds between some of these so-called varves, regularly spaced between these laminated shales. These represent numerous volcanic eruptions. Now, each volcanic eruption, and therefore each volcanic ash bed, corresponds to a single event. We call that an event horizon. Okay, that means you could take any 2 of these volcanic ash beds, and if each represented a volcanic eruption at a unique time, there ought to be exactly the same number of varves between those beds anywhere you go. Okay? If this occurred in 1920 and this volcanic eruption occurred in 1960, you would expect to find 40 varves anywhere you looked throughout this depositional basin. Well, at Kemmerer, near Kemmerer, we have 2 volcanic beds, each about 1 inch thick, and they're separated between them are 3.5 to 9 inches of shale. Yet at 2 different locations, when you count up the laminae, there's 1,089 in one location and 1,566 at the other location. An increase of up to 35% in the thickness of these laminae as you go from one place to the next. So they can't be, these volcanic eruptions occurred at the same time at both locations. Therefore, these laminae can't represent varves, counting up years. The organic content also changes, and therefore they cannot be annual depositional layers. Otherwise, you would have constant thickness and constant organic content across the basin, the sedimentation basin, if they truly were varves. The Green River Formation also is rich with well-preserved fossils that are abundant throughout these laminated shales. For example, enormous quantities of fish, amphibians, turtles, lizards, snakes, crocodilians, birds, bats, mammals, snails, clams, spiders, ticks, and so the list goes on, including well-preserved flowers. We even find the skin and soft parts of catfish preserved. And we even find fossils of fish eating other fish. In fact, this is a photograph of one of the specimens that we have out there in the museum just outside the Special Effects Theatre on the first floor. Did it take millions of years to fossilise that fish? How do you fossilise a bird slowly, or a bat? Here's another example. Here we have a leaf. Part of it is within the bedding of the valve, and the other part of it cross-cuts the valves. How could that be fossilised if each of those layers, valves, was a year? Wouldn't the leaf rot through all that period of time? So how does one explain such extraordinary circumstances of fossilisation when the sediments are supposedly accumulating at a rate of 6/1000th of an inch per year? I mean, how do you bury a fish or a bird at that rate of sedimentation so it will be preserved? They say, but there wasn't oxygen around to rot. I beg your pardon. Fish will rot when you've got no oxygen because you've got bacteria that live where there's no oxygen. Exquisite preservation of fossil fish, birds and bats and flowers requires rapid burial and rapid accumulation of the sediments. So the Green River Formation cannot consist of valves. Instead, it must be due to rapid deposition by storm events that swept these materials together in this lake. Well, do we know of such an event that produced rhythmites as a result of catastrophic deposition? Yes. In Washington State, we had an ice dam that had dammed up glacial Lake Missoula that broke, and in a matter of days, the channel's scabland was cut out. Canyons over 100 feet deep were eroded through solid basalt as if it was as soft as butter. And in the backwaters, where the things swirled around and sediments were deposited, in that one extreme depositional event, we built up these rhythmites. They're called the Touchet Formation, and here they're exposed in Burlingame Canyon. And there was another one as well, exposed also in the Walla Walla Valley. Both of these canyons were produced rapidly too, by the way, as a result of human errors. But this formation is over 300 feet thick, and it consists of 6 to 40 rhythmites, variations in the beds of sand, silt and clay that look identical to valves. And yet it was the result of catastrophic flooding that carved out the channel's scabland. So here's a closer look at these rhythmites in Burlingame Canyon, and here we can see a closer look at them again in the Walla Walla area, the Walla Walla Valley of Washington State. Now, going back to valves. Extensive studies in Sweden and North America have attempted to combine sequences of several hundred laminae considered to be annual valves, but that ran into trouble. A suggested chronology of 28,000 years for North America was actually reinterpreted downwards to only about 10,000 years based on radiocarbon dating. They didn't count them because they're so thin. They didn't bother to count them. Instead, they used radiocarbon dating. And so the valve chronology was calibrated against radiocarbon. And they found that the 30 radiocarbon dates that they used generally increased with depth. And yet we're told that the counting of the valves is supposed to be more reliable than the radiocarbon. But the valves, which are usually corrected by valve counts, and yet we've just seen that that valve chronology in North America was revised based on using radiocarbon dating. Again, it's circularity in the argument. But what about the rhythmites issue? On the left, we know that these were rhythmites. On the right, they're called valves. Can you see the difference? They're virtually identical. Here we see the rhythmites in Burlingame Canyon on the left. On the right, we see ancient rhythmites in rocks in Wales, in Britain. On the left, we see so-called valves in glacial Lake Missoula. On the right, we see catastrophically deposited rhythmites at Mount St. Helens. See the similarity? Coarse grain layers and fine grain layers. So, many sedimentary layers in the geologic record consist of these laminae that may well have been deposited rapidly in storm conditions. They might look like varves, but are in fact rhythmites similar to the catastrophically deposited rhythmites at Mount St Helens, which can also be replicated in the laboratory. Well, let's sum up. So is varve dating reliable? Absolutely not. There's no guarantee that alternating laminae are indeed genuine annual varves rather than multiple rhythmites catastrophically deposited in storm events. Even counting varves fails when the varve counts are cross-checked with radiocarbon dating of the same varves. Thus, varve dating is not independent of radiocarbon, but depends on it, even though radiocarbon is calibrated against tree ring dating, which is calibrated against radiocarbon. Yet, we have these old earth Christian geologists vigorously parroting these as claimed methods, as claimed proofs that we've got agreement between varve counts, radiocarbon and tree rings. Well, of course they agree. Why? Because they've been calibrated against one another. Neither the varve dating, nor the radiocarbon dating, nor the tree ring dating is independent. All three methods depend on one another. They are cross-calibrated in circular reasoning loops that force them to agree. So don't be fooled when you see these examples on skeptics' websites, because they are based on self-deceptive sleights of hand. The claimed ages are ultimately the result of the self-assured infallibility of the uniformitarian assumptions applied to deposition of sediments in the radiocarbon method. What I mean by uniformitarian assumptions, that the present is the key to the past, that you can extrapolate present-day processes back into the past. So, overall conclusions, radiocarbon dating is not reliable without calibration for most known historic objects beyond 400 BC. Most radiocarbon dates do not match tree ring dates and diverge seriously beyond 1000 BC. Radiocarbon dating is still calibrated against tree ring chronologies, but tree ring chronology can only be constructed using visual cross-matching and wiggle matching, both of which are subjective, and tree rings are calibrated against the radiocarbon dating method. Varves are identified ignoring the likelihood of rapidly deposited multiple rhythmites from regular storm events. Constructed varve chronologies have had to be corrected using radiocarbon, drastically reducing the numbers of claimed counted varves. So in fact, they must instead be rhythmites. And claimed examples of consilience or agreement of these three methods are based on sleights of hand due to the self-assured infallibility of uniformitarian assumptions. The bottom line is, none of these dating methods is reliable, independent or objective. Only radiocarbon dating may yet be objectively recalibrated using the biblical chronology and objects of verifiable historic ages. So thank you very much for your attention and your attendance, and God bless you as you travel to your homes.